lesson number 3, Algebra, Volume 4, application number 7, or set M equal product Cartesian and multiplication n. On the set M are introduced law of composition. X, y at z, w equal definition x at z, comma y at w. X, y multiply x, w equal x, y at y, w, comma x, w at y, z. Whatever pair x, y, and z, w of M show that these laws of composition are associative, commutative, and neutral element. If x, y equal x, e at y, e equal vector v1, where e and g are unit vector axis y, ox, y, respectively, x, y plane, z, w equal z multiply e at w, e equal vector v2, vector v1 at plus vector v2 equal x, e at y, g at z, e at w, g equal x at z multiply e at y at w multiply g equal x at z, comma y at w. Coordinate. It follows that the first law composition plus is like vector addition plan x, y, or any plan x or z, y or z. Law plus is associative. Any x, y, z, w, v belong M, set M, x, y at z, w at v equal x, y at z, w at y, w, x, z at y, y, w at u, v equal x, y, z at u, w at v, x, z at u, comma y, w at v equal x, z, u, comma y, w, v, x, z, u equal x, z, u, y, w, v equal y, v, w. It follows that law is associative. Law plus is commutative. Any x, y, z, w belong M, x, y at z, w equal z, w at x, y, x, z, comma y plus w equal z at x, comma w at y. X at z equal z at x, y plus w equal w plus y. Check. So the law is plus is commutative. Law plus admit neutral element. Any x, y belong M exist x index n, comma y index n belong M such that x, y at xn, comma y index n equal xn, comma yn at x, comma y equal xy. X at xn, y at yn equal xy. X at xn equal x, y at yn equal x. Xn equal x minus x equal 0, yn equal y minus y is 0. Xn equal x index n equal 0, yn equal 0. 0, 0 is the neutral element. Now study A, associative, C, commutative, and neutral element for the second law of composition, multiplication. X, y, multiplication z, w equal x, z at y multiply w, comma x, w at y, z. X, y multiply z, w. If you want to work which vector of plan xy? X, y equal xi at yj. Z, w equal zi at wj. Value e equal value j equal 1. Ox and y axis are unit vector. Xy multiply zw equal xc at yj multiply zi at wj equal xz at yw. E multiply e equal e value e multiply sides e cos 0 equal 1. E multiply j equal sides e multiply sine j cos p divided to equal 0. Cos p divided to 0. J multiply j equal sine j multiply sine j cos 0 equal 1. Multiply size j equal size e equal 1. J multiply e equal size j multiply size e cos p divided to equal 0. Figure 3, plan x or y, axis x, axis y, vector v xe at yj, point mxy, xe, yj, for 0 equal 1. So the multiplication not coincide as vector addition. Xy multiply zw equal z at yw, xw at yz. Love is somewhat. Somewhat. The love is associative on M, or xy belong M, zw belong M, and uv belong M. Xy multiply zw multiply uv equal xy multiply zw multiply uv. Xz at yw, xw at yz multiply uv equal xy multiply zu at wv, comma zv at wu. Result check. So the law is associative M. The law is commutative on M. Any xy zw belong M. Xz at yw, xw at yv equal z, zx at yw, zy at xw. Check. So law is commutative. Law admitting a neutral element. Any xy belong M, exist xn, yn belong M, such that x y multiply xn yn equal xn yn multiply x y equal xy. Xn at yn multiply comma xyn at y multiply xn equal xy. Result xn at yn equal x, xyn at yn equal y. Multiply first equation minus y, second equation x. Result yn multiply x power 2 minus y power 2, xn 0, yn power common, factor common, x power 2 minus y power equal 0 minus xy equal 0. Result yn equal 0 and yxn at xyn equal n, yxn equal yxn equal 1. So the neutral element is 1 0 belong M. Application number 8. Or S equal product Cartesian z product z power where z power equal z minus 0. The set S introduce the following composition law: xy at zy equal xw at yz, comma yw, and xy zw equal xz yw. Water pair xy and zw of S. Show that the law of composition associative, commutative, and has a neutral element. Associative law plus is associative of S. Any xy zw uv belong z, xy at zw at uv equal xy at zw at uv, xy at zv at wu, wv equal xw at zy, yw equal uv. xw at y multiply zw at wu, yw equal xw at zy multiply v at yw, ywv. xw y zw at yvw egal to xw at zy multiply v at ywu. Check. So the law is associative S. Law plus is commutative. C on S. xy at zw equals zw at xy, xw at yz yw equals zy at wx wy. Check. So the law plus is commutative. Law plus has a neutral element n on S. Any xy belong S. Exists x index n, y index n belong S such that x multiply x, y multiply x index n, y index n, y index n equal x and yn multiply x, y equal xy. X multiply yn at y multiply xn, yn equal xy. Xyn at y xn equal x, y multiply yn equal y, yn equal 1, x yn at y xn equal x, x at y xn equal x, xn equal 0. The neutral is xn yn equal 0 1 belong S. We studied the second law multiplication. The law is associative A on the set S. xy zw uv belong S. X, y multiply zw multiply u, v equal x, y, y multiply z, w multiply u, v. xz yw multiply uv equal xy multiply zu, vw. xzu, ywv equal xzu yvw. Check. To law multiplication is associative. The law is commutative. Any xy zw belong S. xy multiply zw equal zw multiply xy, xz, yw equal zx yw, zx equal zx, yw equal wy. Check. So the law is multiplication is commutative. Law multiplication admitting neutral element n of S. Any xy belong S. Exist xn, yn index n belong S such that x, y multiply x index n, y index n equal x index n, y index n multiply x, y equal x, y, x xn multiply yn equal xn, x xn equal x, y yn equal y, xn equal 1, yn equal 1. Neutral element is xn yn equal 1 1 belong S is the neutral element. So application number 9. On the set n of natural numbers, we define the composition law compose product Cartesian set nature n, product n, value n, mn equal m compound n equal m power n. define m compound n equal m power n. Prove the law of composition properties. Determine the triple MNP of non-zero integer such that m compound n compound p equal m compound n compound p. The law compound is associative. Any MNP belonging m compound n compound p equal m compound n compound p, m compound n m power n compound p equal m compound n power p. M power n power p equal m n p, m n p equal q m n p, n p equal q n power p is of only the p equal 1. So we mn1 for stapler or np2 and m equal n. np equal np, 2 multiply 2 equal 2 power 2, 4 equal 4, so m2 2 of the second triplet. Associative law compound is not wide, having some restriction. So the law is not associative. Law compound admitting neutral element any m exists xn belong m such m compound xn equal xn compound m equal m. M compound xn equal m power xn equal m. Xn equal 1 neutral element. Xn equal 1 belong n. Total law do not allow neutral element. Law compound admitting symmetrical element. Any m any m xn equal 1 belong m exists xs. xs belong m such that m compound xs equal xm. M power xs equal 1. Result xs equal 0. Symmetrical element xs equal 0 not belong nature m, set nature n, number n, so the law does not allow symmetrical element. The law compound is commutative. Any mn belong n, m compound n compound m, mn equal nm only if m equal n, so is not commutative law n. Allow only with certain restriction. Take the associativity mn1 and m2 to triple.